Welcome to the Crypto Guild. I'm your host Rahul, and on this channel we talk everything crypto. So let's get into today's topic. Today we're going to talk about proof of stake. It's a consensus algorithm that's used by many of the top sort of blockchain projects out there. Ethereum 2.0 is going to use it, Cardano uses it, and a whole bunch more. So let's get into understanding what it is, what is consensus, what do these sort of consensus mechanisms like proof of stake, what do they actually do, why are they needed, so on and so forth. So let's start.
All right, guys, let's get started here. So before we move into the specifics of proof of stake, it's important to understand consensus, right? Consensus as a concept, right? Because at the end of the day, proof of stake is nothing but a type of consensus algorithm, right? And there are many different types, right? Proof of stake and proof of work are some of the most common ones used. But I think what we'll do is look at sort of the key components in a blockchain and sort of understand where consensus fits into those key components. And once we have an understanding of what that is, we can then look at the specifics of proof of stake. So let's get started. So first up are the users. So the users refer to folks such as yourself and myself. And essentially, we are all doing transactions on any particular blockchain project such as Ethereum or Bitcoin. Next up, we have a temporary transaction pool. So you can think of this as sort of like a temporary pool where transactions are stored, again, just temporarily. Third up are the validators. So the validators have two roles essentially, right? So their job is to commit transactions to the blockchain. So creating a block and committing it to the blockchain. And then their second job is to verify transactions, right, on the blockchain. So if let's say there are like 100 different validators, right? A couple of them might be chosen to commit the transactions, to create blocks and put the information in the blockchain. And then the remaining sort of validators will be used to actually verify those transactions, right? So third, we have, or fourth rather, we have the blockchain itself. So you can think of the blockchain as sort of like a distributed database, right? Which actually stores the permanent record of all transactions, right? So whatever's written in the blockchain is essentially treated as gospel. It is the truth, right? For that particular blockchain project. So let's look at the flow of information between these sort of like four entities. So users, as we know, they initiate transactions and the transactions are stored in the transaction pool, right? Then validators, certain validators, right, are chosen to actually go fetch those transactions and order them correctly, right? Because the pool has a whole bunch of transactions being recorded. You want to fetch and order the correct ones, right? To eventually insert them into the blockchain, right? To commit them into the blockchain. So next up comes the activity of the selected validators to actually forge, right? We use this terminology instead of creating a block, we use the terminology of forging a block in proof of stake systems, right? So they'll forge the block and they will commit the transactions to the block. Next, once that's done, now the remaining validators, right, their job will be to actually validate the transactions, right, that were just created or forged, right? And typically what happens here is that you need to have a majority amongst the remaining validators. That in simple English means they need to agree. All of them need to sort of collectively agree in a majority kind of way regarding the block that was just formed and the transactions with it. And so if everything looks, good, they sort of attest it or tell it or tell you that it looks fine, and then they move on, right? And then obviously the creators of the block, they earn rewards for their job of writing the blocks to the blockchain. So next, before we move on, all the arrows you see in orange are essentially sort of part of the consensus related like activity. So as you can see over here, validators are core, right? They're the core concept when it comes to consensus, right? Because they are sort of like the ones who write the information into the blockchain, and they are the remainder of them are used to actually validate that information that was just written into the blockchain. So next up, let's understand consensus in the sense like, why do we even need this, right? Why do we have this complicated mechanism of some guys writing blocks, other guys validating blocks? What's the use? So number one, since the blockchain itself is sort of like the truth or the system of record for that entire like project, the job of consensus is to make sure that everyone reaches a common understanding or agreement on the current state of the network, right? Just to make sure that all the balances are absolutely reflecting the transactions that occurred on the network, right? Second, consensus is actually used to secure the network. So this method of actually having some validators write blocks into the blockchain and having the remaining validators sort of verify those, that information, this entire sort of step or these processes, right, are done primarily to secure the blockchain network, to make sure that the information being written inside the blockchain, right, which is nothing but a distributed database, is absolutely accurate. And sort of one of the third big sort of function of a consensus mechanism or algorithm is to de-incentivize sort of economic attacks. So this is popularly known as the 51% attack in the crypto universe. So what that really is it's saying that if a bad actor got access to 51% of the sort of resources of that network, right? In this case, it would be sort of 51% of the stake, really, or in proof of work, it would be 51% of the hashing rate or the mining power. So essentially having majority control over whatever consensus mechanism is being used, right? So the whole idea is to disincentivize it, meaning even if a person did go ahead and sort of, go ahead and collude or put in like fake transactions or try to give themselves a whole bunch of money, all of that would actually be negated by the fact that consensus has an inbuilt mechanism for penalties, right, related to such behavior. And we'll talk a little bit more about that in proof of stake. But suffice to say that the consensus mechanism disincentivizes these economic attacks. It just makes it sort of not viable from an economic perspective to do these attacks. You would lose significantly more than you would gain, right? So consensus helps you sort of like enable that. And just a few things or a couple of things to keep in mind. First of all, as I mentioned before, proof of work, also known as POW, and proof of stake, sometimes known as POS, are two of the most common consensus mechanisms or algorithms found in blockchain projects. And another thing you should know is that I'm going to talk about the specifics of proof of stake, but in a sort of basic way. And I'm saying in a basic way because each different project like Cardano or Ethereum, all these projects implement these consensus mechanisms in a slightly different way, right? And so they're never exactly the same across different projects. So you got to keep that in mind. So it's better to understand the concept of consensus and the concept of proof of stake, and you might see sort of variations of them when you actually go inside in depth into different blockchain projects, right? Next, let's get into understanding sort of like the basic sort of proof of stake, right? This will help you guys sort of understand how, from what you understood as consensus related activities, how we now have a specific type of consensus algorithm, right? Such as proof of stake. And again, I'm using the word basic version because every project kind of does it slightly differently, right? But if you understand this, you will be able to understand sort of the nuanced differences in which these projects operate. So let's look at our ecosystem again, and let's have a look at our validators. So in a proof of stake sort of consensus model, what happens is that each validator is asked to commit a certain amount of coins, right, into the network, or this is called staking of coins, right? So different validators may put in different amounts of coins, right? But the idea here is that if you want to become a validator, certain blockchains mandate that you have a minimum stake. So if I go with the example of Ethereum 2.0, your minimum stake size is 32 Ether, right? So you need 32 Ether to qualify as a validator on Ethereum. Next, the block creators, meaning of the entire pool of validators, the block creators, the ones who are actually going to take the transactions from the temporary transaction pool, they're going to order them, and they're going to actually go ahead and put them into the blockchain. They're going to forge them into the blockchain. Those guys are chosen sort of in a pseudo-random manner, right? And I'm calling it pseudo-random because the size of your stake is, or how many Ethereum in this case, if we're going with the same example, how many Ethereum you've staked on the network, the size of that stake is one of the factors that is used, right, to figure out like who should be the validators, right, to actually write the transaction into the blockchain. But if you look only at staking size, that would obviously favor the validators who have a large stake in the ecosystem. So to make it fair, typically, along with stake size, there are many, or a couple of at least, different methods that are sort of employed. So coin age selection is one, right? Where what they do is they look at how long a particular validator has staked their coin. So let's say you staked it like 10 days ago, and based on that and sort of what your stake size is, suppose you're selected to actually go ahead and forge a block and commit the transaction. What happens is then your coin age is then reset back to 0. So then next time around, the network won't pick you. It'll wait for some time till your coin age, kind of comes back and give other folks, a chance at becoming a block creator, because the block creators are the ones who earn sort of rewards. So generally speaking, the system or the network is trying to make this process as fair as possible. It uses stake size, coin age selection, but again, this is sort of like I'm giving you a very high level basic understanding. Different blockchains have different methods, right, to make this fair. And as I mentioned before, the remaining validators verify the transactions that were forged by the validators who were selected previously, right? And so the remaining validators typically, again, this varies, but typically, as long as they reach a majority on what the contents of a particular block, meaning which are the transactions that are meant to be in a particular block and that they look good, that is the role of the verification aspect of this, right? And one other thing to keep in mind is that staking in general, it incentivizes good behavior. We touched upon this previously, but essentially there are major penalties for deliberate collusion. You could lose your entire stake, right? And you even get, what they call slashing penalties, which is to say that suppose you don't perform your role as a validator appropriately. Like suppose your computer is turned off and you've said you wanted to be a validator and the network tried to select you, but you weren't available. In those cases, you'll get a penalty where some of the stake that you have, right, will be slashed or taken away from you. So generally speaking, this is sort of like, the system by which it keeps people sort of honest, because typically the stake you have and the rewards you earn, your stake will always be higher than your reward. So for you to go ahead and deliberately, try and game the system, your loss will always be significantly higher than your gain, right? And that's what the, consensus, it's in your best, or the validator's best interest, to behave in a good sort of way. So I know that was a lot. I'm trying to keep this high level. So let's just do a quick recap of what we've learned thus far about consensus and proof of stake, right? So first of all, consensus algorithms or protocols are fundamental to any blockchain, right? And it essentially refers to the process of validators creating and validating blocks, right? To reach agreement on the current state of the network, to secure the network, and to disincentivize economic attacks, right? Or more popularly known as the 51% attacks, right? And proof of stake and proof of work are two of the most common consensus mechanisms, although each blockchain project has slightly different implementations of these consensus algorithms, right? And then specifically in proof of stake, you stake your coins in order to become a validator. The network utilizes certain pseudo-random algorithm to decide the next block's creators and verifiers, right? And as we just discussed, staking incentivizes good behavior as there are penalties, or also known as slashing, for bad behavior, such as not being available for a validation when selected or indulging in deliberate collusion. So guys, that was a sort of basic understanding of consensus and then of what basically proof of stake is.
Hey guys, I hope you enjoyed that. Hopefully you have a better understanding of what consensus algorithms are and what a basic proof of stake consensus actually looks like, right? I do try and cover content for both beginners and advanced users. So if you like the explanations in the video, definitely subscribe so you know when the next video is going to drop. And until next time, peace.